Hi, this is Julia Bell. Welcome to Chapter 3, 3-Part 1, Networking Protocols. Rules of Communication. Here's a picture of one of my Cisco classes in their team building exercise. Standards organizations. Those include IEEE, EIA, ITU, ICANN, IANA. IANA, of course, assigns the Internet numbers. Used to be IP version 4. Since we've ran out of those, now we're using IP version 6, which is a much longer address. There's also TIA and ITF. Here are a list of the websites for those folks. Establishing the rules of communication. You identify the sender and the receiver. You agree upon the method of communication, whether that's face-to-face, telephone, letter, photograph. A common language is something you look for. If we're both speaking English, we'll have no problem understanding each other. But if one of us is speaking French and the other English and neither one of us understands the other language, we've got a barrier to communication. Speed and timing of your delivery and getting confirmation of acknowledgement of those requirements. Message encoding. You start out with a simple message, prepare it to send it via the transmission method, whether that's a human opening their mouth and speaking, or whether it's using a cell phone or some other method. What is your channel? If it's just face-to-face, it is just words from one mouth into the air, into the other one's ear. The receiver on the other side has to be able to understand and decode, again, both speaking the same language, and then the message has actually reached its destination. Message formatting and encapsulation. Personal letter is a good example. In our example, we have a sender at the top left in Florida and a recipient. For the letter to get to the recipient, you've got to have, of course, a street address, a name of a street, a city, state, and a zip code. If it cannot reach the recipient, you need to have the same type information at the top left for the sender. Their complete address, the city, state, and zip, so that if it doesn't go, they get the return. Message size. The size restriction of a frame, which we'll talk about later, requires the source host to break a long message up into individual pieces that meet both minimum and maximum size requirements. They can't be too small, they can't be too large. If they're too small, you pad those with extra zeros, and it's done by the equipment. This is known as segmenting or breaking up a message. The segment is then encapsulated into separate frames with the address information, and it's sent over the network. At the receiving host, the messages are de-encapsulated. You take those layers of encapsulation off and you put them back together to be processed and interpreted. I'm going to put the movie Warriors of the Net in this week's assignments for you to watch and give me your feedback on. Message timing. Here we talk about access method, flow control, and response timeout. The access method. If two people talk at the same time, a collision of information can occur, and it's necessary for the two to back off and start again. It is necessary for computers to define an access method, how we're going to communicate. Hosts on a network need an access method to know when to begin sending messages and how to respond when an error occurs. Flow control. It's a method used by two computers to ensure that packets are not dropped because too much data is being sent too quickly. In network communication, a sending host can transmit messages at a faster rate than the destination host can receive and process. Source and destination hosts use flow control to negotiate correct timing for successful communication. Response timeout. If a person asks a question and doesn't hear a response within an acceptable amount of time, the person assumes that no answer is coming and reacts accordingly. You might repeat the question, or you might just assume you're not going to get an answer. In a network, the hosts on the network also have rules that specify how long to wait for responses and what actions to take if a response timeout occurs. Message delivery options. We're going to talk about unicast, broadcast, multicast, and how those are different. Unicast. Unicast is going to be one-to-one. Unicast. There is only one destination for the message. In our picture here, if the young lady were speaking only to the gentleman in blue, that would be an example of a unicast, one-to-one. Conversation between two people is an example of one-to-one delivery or unicast. Multicast. A computer in a given network is communicating with a specific group of computers, maybe all the accounting department, for instance. One-to-many delivery option is referred to as multicast. more than one recipient. Multicasting is the delivery of the same message to a group of host destinations simultaneously. So one to many or one to a group. Broadcast. If all hosts on the network need to receive the message at the same time, notice the word all. If all hosts, a broadcast is used. So broadcast is one to all. Broadcasting represents a one to all message delivery option. This is the end of section 1.